The European Enlightenment and scientific revolution was a time of great discovery and questioning mostly during the 16th and 17th centuries that led to popular ideas and experiments that have left a lingering impact on society today. Without the time of the Enlightenment and scientific revolution, we would not have any understanding of science or mathematics to the extent that we do today. This will focus on Newton and Galileo, two scientists with the huge impacts left on today's society from the scientific revolution. Our first trip was to eat lunch with Galileo Galilei in 1638, after his book Dialogues Concerning Two New Sciences was published. We visited Galileo to learn more about his studies in sciences and aspects of his personal life that led to his findings. From talking with Galileo, we learned that he studied at the University of Pisa. Galileo decided to study science as a potential answer to his questions about the universe. Along with his sense of curiosity, he was also interested in the research of scientists that preceded him. Galileo was the first to successfully implement the use of the telescope, and he also discovered that the idea that force causes motion. He also came up with the law of falling bodies, which states that all objects accelerate at the same rate despite differences in size or mass. Galileo affected the lives of people from his publishings of his book and now has a lasting role in today's society. His role also affected other Enlightenment thinkers of the scientific revolution, such as Newton, to further expand his findings.
Suppose you had a very heavy ball like a bowling ball, and another ball of the same size and shape but much lighter, like a volleyball. Which one would hit the ground first? The ancient Greeks had thought about that problem. In fact, Aristotle had said the answer was obvious. He said that the heavier body would fall faster than the lighter one, and that its speed would be proportional to its weight. But Galileo had a different idea. He said that regardless of the weight of the two bodies, they would reach the ground at the same time, at least so long as the air resistance was about the same for each body. And about a century later, we had a more complete explanation for why that is. It's true that the heavier a body is, the more strongly the Earth's gravity pulls on it. But the larger body also has more inertia, which makes it more resistant to being accelerated.
After learning about Galileo, we have decided to further our research on the scientific revolution by meeting with Sir Isaac Newton for lunch in 1705, who based much of his findings and research on Galileo, and coincidentally was born the same year that Galileo died, 1642. Newton combined the ideas of Galileo, Copernicus, and Kepler, which was a continuity but also an expansion on previous ideas from scientific thinkers of this period. He attended Cambridge University in 1661. Optics, mathematics, and mechanics, gravitation, alchemy, and chemistry were all areas of study that Newton focused his research on. Newton was interested in the study of science and mathematics for much of the same reasons as Galileo. Based on his experiments, Newton came up with three major laws. The first law states that an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This is called the law of inertia. The second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. This is represented by the equation net force equals mass times acceleration. The third law states that for every action, there is an equal and opposite reaction.
Newton's discoveries were huge milestones in concepts in physics and mathematics, which left impacts on today's society as well.
From the time period of the scientific revolution, one change was the role of the church in society, because the scientific revolution gave new explanations to ideas about nature, such as gravity, rather than it happening solely by God.
Another change was the way technology worked and was used. This is needed because of the advancement in thinking from the scientific thinkers. Also, because this was a revolution, not many of the ideas stayed the same.
After talking to Newton, we discovered that Galileo was put on house arrest because the church did not agree with his theories. During this time, Western Europe was becoming more intellectually and technologically developed when compared to other civilizations, which set this revolution apart from others. One reason for this is because China, in the later stages of the Ming Dynasty, chose to close itself off from outside influences.
After talking to both scientists, we have concluded that these concepts, that were once new ideas for both Galileo and Newton, have become known facts proved with evidence and years of research. Furthermore, Newton's concepts of physics can apply to everyday life outside of school or textbook, such as driving or sports.